attention what they're asking us to find. Compute the derivative of the given function. Find the equation of the tangent line to its graph for the specified x value. Well, eventually I'm going to have to find the equation of the line, so I'm going to go after the point before I start, and it's x equals 5. So the next question is, what's y? Well, f of 5 is 2 minus 7 times 5, which is 7 minus 35, or minus 33. So in the end, I'm going to need that coordinate point, because whatever's going on is at x equals 5. So this is where the graph touches. So tangent line touches here. So that would be the dot on my graph. Well, in order to do this, remember what f prime is. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. This is the algebra part. So I'm going to compute this first. And by the way, on Canvas, I have a module in there that talks about four-step process, what we do in algebra, what I'm actually going to be doing Monday morning in college algebra. So it talks about it, gives you examples and that kind of stuff if you need help in that area. So I use something called the four-step process. In other words, I compute f of x plus h, then f of x, subtract the 2, and then put it over h. So step 1, it says find f of x plus h. Well, it's 2 minus 7 times x, which is x plus h, which is 2 minus 7x minus 7h, h. And I can't do anything with that. Second is just the original function, which is 2 minus 7x. The third step is taking what I got in step 1 and subtracting what I got in step 2. So that's f of x plus h minus f of x is 2 minus 7x minus 7h, subtract more than one term, and if I've done this correctly, I should end up with nothing but terms that have h's. So this is 2 minus 7x minus 7h minus 2 plus 7x minus 2 plus 2 minus 7x plus 7x minus 7h. If I've done something wrong, if I'm dealing with a polynomial and I don't end up with terms that have nothing but h's. Now I'm going to take what I got in step 3 and divide that by h. So that's f of x plus h minus f of x all over h, which is minus 7h over h. H's drop out, minus 7. This is the slope of the secant. Now what you have to remember, what I'm dealing with is a straight line. So I've done the algebra part. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h, which is the limit as h goes to 0. This whole thing gets replaced by negative 7. That was the calculation. And what's the limit as h goes to 0 of negative 7? Is there an h with negative 7? Do you see an h here? So as h goes to 0, what happens to negative 7? Does h change him? H can't change him if he's not there. Negative 7 is a constant. Constants don't change. So the limit as h goes to 0 of negative 7 is negative 7. So this is also the slope of the tangent. So to find the equation of the tangent, I need the slope of the tangent, which is negative 7. I need a point, which is 5, negative 33. And I personally use point slope form. Y minus y1 equals m times x minus x1, or y minus a minus 33 equals negative 7 times x minus 5, or y plus 33 equals negative 7 times x minus 5. That's a perfectly good answer, by the way, because they didn't say what form to put the answer in. But the bottom line ends up being how I express that depends upon how I'm going to use it. Because I can express it in general form, I can express it in slope-intercept form. But if I want to put it in slope-intercept form, y plus 33 equals negative 7x plus 35, or y equals negative 7x plus 2, which happens to be the original equation. So the equation of the tangent line is the equation of the original line. Why would that be? Why would the equation of a tangent, and let me draw what this guy might look like. Why would the equation of the tangent be the same as the equation of the original equation? Because it's a straight line. If I were to pull 533 off, maybe that would be it, draw a tangent line, where would the tangent be? On the line, because the tangent line is a line and the line was a line. So it should be the same as the original.